charts are more visually appealing when the slices are different sizes. Each slice represents a category. The area of each slice represents the proportion of the total occupied by the category. Yep. Sounds like little quizzes like.
I hope you go for number 3.
What?
I think we should go for option, what was that, C?
Yeah, it's just random. Okay, number 4. How are bar charts and Pareto charts related?
What is a Pareto chart?
Okay, let's see here. Pareto charts.
Oh.
Okay.
So I think a bar chart.
Is a bar chart where the bars are presented in descending order?
That's Pareto.
Yeah. So the only difference between a bar chart and a Pareto chart is the bars in the Pareto chart are ordered largest to smallest. Okay, we conclude that p hat is normally distributed if np is greater than or equal to 10 and n1 minus p is greater than or equal to 10. Is p the true proportion or the sample proportion? Isn't p the sample? Let's see here. I think it's the same, but okay, where p is the true population proportion. So p hat must be the sample. Is that what you're getting?
P hat is a point estimator for the true proportion P.
Yeah, and p is the true population proportion. So, okay, so is p the true proportion or the sample proportion? So true proportion. What is n? Sample size.
Yep. Right?
Yeah.
I mean, that's what it has been. I don't think it's changed.
Yeah, I'm pretty sure. Right.
Yeah, sample size.
Wait. Sample proportion p hat is normally distributed if n is large. The true population mean of the random variable p hat is okay. I don't know why I said that. Never mind.
Okay.
Okay. So we're looking for
P.
if p equals 1/4, what is the smallest n that satisfies the requirement? Is it okay.
So if we find P hat, have we basically found P? Could we say that? Because there's an equation here that uses P hat, where P hat equals X divided by N.
So is the x 1/4 for this? Wait, X. Wait, P equals 1/4. Oh, okay.
So we want to find P.
So okay. P equals 1/4. What is the smallest n that satisfies the requirement?
Finally, the last bullet point is that the X bar has a sample distribution, but also P hat has a sample distribution of all possible sample proportions. So this
This
distribution
is not helping. Come on, video.
sample means all possible sample means. And over the right is distribution of all possible sample proportions. Let's go further. First, distribution of X bar left versus the distribution on the right. All possible sample. You can also get a z square root of sample size. Something from the same proportions.
Okay. Mm. I think it's something really simple. Can't remember what it is. This is lesson 16. Oh. I think isn't there like a rule of 40 or something?
Excuse me.
Oh my gosh, my internet's so slow that I can't do anything. Okay, I think I get it. Okay. So let's see here. It's asking us if P is 1/4, you plug in P to this equation, okay? Then, so this is 1 minus 1/4, I think. 1 minus 1, okay. So it's going to be point, times it by n. You plug it into one of these equations, and it has to be greater or equal to 10 in order for it to satisfy it. So you have to, okay. 1 minus P. N, oh. Okay, so n times P. So P is 1/4, so we have to find the n. So
That makes it greater than 10.
yes, so 1/4. So 0.25 times it by 40 makes it greater than or equal to 10.
Okay, so do we just plug in numbers until we find?
I think so. Yeah, until you get to 10. So okay. Oh, and n1 minus p is greater than or equal to 10. So 1 minus p is 0.75 times it by an n of 40, right? That's what we said. So 40 times 0.75 is 30. So that's greater than or equal to 10. So it satisfies it. So the answer
It's 40.
is 40 because that's the smallest amount for it to satisfy the 10 rule.
Yeah, because 39 puts it under 10 when you multiply them together.
Yeah.
And I don't know what those ones.
Yeah. So, okay.
Okay. So for 8, I got 0.4 since P hat is equal to P. And then the standard deviation I got is 0.1. And in your book, on that remember part, it says the sampling distribution of P bar has a mean of P and a standard deviation of, and it gives you the equation for that. And it's square root P times parentheses 1 minus P close parentheses divided by n. And so you just plug the numbers it gives you in. And
What was the formula one more time?
square root of P times parentheses 1 minus P close parentheses divided by n. And that gave me a 0.1.
0.1 is what you got for P hat.
Mm-hmm. So then down on 10, same thing. P hat would be 0.30 because it wants 2 decimal places. And then standard deviation, I got 0.046.
For 9.
For 11.
What did you get for 10?
0.30.
Oh, okay. I thought that was what you got for 9.
Oh, no, 9 I got 0.1.
Oh my gosh, okay. Sorry, I'm off one number.
Oh, that's fine.
So,
So 9, I got
what's 8?
0.4.
0.4, okay. And then
And those, I don't know if we need to put 3 decimal places or not.
okay, I'll do it just in case. Then
9, I got 0.1. 10, I got 0.30.
0.30.
And 11, I got 0.046.
0.46.
And then I was on 12.
Okay.
So to get the z-score,
So the z-score formula is value
p
or
hat
p hat minus p divided by the square root of p times parentheses 1 minus p parenthesis divided by n.
But if our p and our p hat are equal, then we just have a 0 on top, right?
Yeah.
If we have a 0 on top, then anything divided by 0 is 0.
So everything will be 0. Wondering if we
Yeah, that doesn't seem right.
okay.
Oh, you know why? Because now we're doing a proportion, which the formula for that is p hat equals x divided by n. And x being observed, which for this question is 35, divided by the total of 100.
Wait, where did you get 35?
In the question, what is the probability Brittany gets at least 35 hits on her next 100
Oh, okay.
at bats? So we would observe 35 and divide that by 100. What happened to your knee?
I was playing soccer.
Ouch.
It was stripped. It was like already cut up from the week before, and I reopened it. So,
That sucks.
yeah.
Otherwise, that would give us a 0.35. 50 because 1 to 3 decimal places.
And this is 10.350.
Yeah. This is what?
10, right?
No, 13.
What is 10?
10 is 0.30.
0.30. And
11 was 0.046.
0.046. And then
12 was top. We're in the middle of 12, and I skipped to 13.
yeah, that's why I was confused. I thought we were going back and checking them because one of the numbers was off.
Let's see, how do we? Oh, Don't we just have to plug in 0.30 into the probability applet?
Yeah, yeah,
I was making that way too complicated.
yeah. Yep, that's right.
Okay, and then our z-score would be 1.036.
1.036. Okay. Yeah, that sounds right. And then what is the probability Brittany gets at least 35 hits in her next 100 at bats? So
And then that was x divided by n.
so it's just 35 divided by 100.
Which is just 0.350.
0.350. Okay, what z-score would you use?
Oh, wait.
Wait,
Were you on 11 or 13?
I was on 13, sorry. I
Okay.
skipped it. I was just getting ahead of myself. Okay, if the true portion of people who support a political candidate is P equals 0.52, and if N equals 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What is the standard deviation of P hat? So we have P and we have N, and
2.
getting less than half of the votes. P equals
So our standard deviation is 0.011.
0.011, and you just plugged in 0.52 and 2,000 into the
Equation, the square root.
P1 minus P divided by N.
Mhm.
Perfect. Okay, what z-score would you use? So
So we have a P of 0.52. Which gives us a z-score of 0.643.
okay. And what probability do you compute using the normal probability applet? Greater than, is it more or less than? Well, it's asking us getting less than 50% of the votes, so wouldn't it be less than or equal to C?
That's what I would think.
I mean, I don't think it makes sense to say greater than or equal to.
Yeah, z is less than or equal to little z.
Okay, and what is the probability the survey results will show the candidate is losing even though the true P equals 0.52?
So when we just take 2,000 times 0.49, take that value and divide it by 2,000. Because for him to
0.49.
for him to be losing, he has to be getting less than 50% of the votes, right?
Yeah.
So that would be 49% or 0.49. And then you take 49% of your 2,000 people surveyed
Okay. That makes
to get the
sense.
number of people observed in the negative, right?
Yes.
And then you take that number as your x and divide it by your n, which is 2,000, to get your p hat.
I think that makes sense. Yeah.
We'll see.
That sounds logical. Sounds logical to me, at least.
So I just get 0.49.
You just got 0.49?
Yeah.
Oh, okay. Well, I don't think that's right.
Yeah.
Something's wrong. Can we just plug in
Or
P hat? That's probably that's right.
or do we just plug in 0.49 into the probability applet?
Oh,
Or 0.52 or
I think we plug in point. Oh, I'm not sure because I'm not sure on this one. Um,
or do we just take p equals 0.5 and highlight all of the area to the left of the z-score? And that would show all of the area that's losing, right?
yeah,
Because in our book, they give us a z-score for p equals 0.5. So if we plug that z-score in and highlight everything to the left of that, that area should be the margin that he's losing, right?
okay.
And then maybe we can do something with that.
Yeah, I think that makes sense. I can see.
So that's an area of 0.902. Two. What do you think?
I think we plug it into the applet and we shade to the left. The value.
Well, it's not 0.902.
Okay.
Hmm.
Um, well, I think it's 0.035, and I think you just have to go in and shade the left-hand portion of on the applet.
But corresponding to what area? Or what z-score?
I think, okay, let me see this. BYUI So we have values to make this. Or, 0.034. Okay. So the z-score is that you use is negative, or so it's 1.818, negative 1.818, and that is okay. So we have to find the p hat, get the z-score, because we have the p.
So would it be, wouldn't P hat equal P times the square root of P1 minus P divided by N?
Yeah.
So then that would make P hat equal to 0.0058 for what we're doing. And then what do you do with the P hat?
Is there a formula just for finding P?
Well, P is given to you. In this problem, anyway. But P is usually found by finding Z. Like you would find Z and plug it into the applet and get P. Let's see, if you do that, you get the P hat that way. And you plug it back into that Z equation, you get a super negative number.
That doesn't look right. Um, um, what's what's Can I see your calculator?
Yeah.
Well, that doesn't work out. No way. Wait, I think something's screwing us up. 10 isn't 0.3. 10 would be 35 divided by 100. It's 0.35, isn't it? Because it's the
Mm-hmm. It wouldn't.
yeah.
But then what would 13 be? The probability that she gets at least 35 hits.
Do we have to do we have to divide by standard deviation? Is that what we have to do? So
To get p hat or for 13?
For 13. So we take 0.35 divided by 0.046. Um, Okay, well, it's gonna change our p-score.
For question 11?
Yeah.
No, that one's right.
Or no, question 12, sorry. That was e-score. Wouldn't it? Because don't you?
Yeah, we're gonna have to change something in 10 and something in 12.
So we did 12 right, we just didn't factor in the 0.35. So if you factor in the 0.35, it's 1.067 for 12.
Okay.
I'm still not sure about 13, how to get that. Because it's wait. I don't know. I think I'm just going to submit mine.
I already did.
Oh my gosh.
I just wanted to see if you could work out what we might have done wrong with 10 or 12. But we also got 15 and 17 wrong.
With the z-scores 0.643.
Mm-hmm. And those I've tried to figure out what we did wrong, but I just can't brain anymore.
We got 10 wrong with 0.35.
No, we got we got 10 wrong with 0.30. So
Oh, Freak, you submitted a long time.
yeah. Yeah, then I got a little distracted. I had to write to Brent. He sent me an email.
So it was 11.
So 11 was right.
11's right. So we got 10 wrong, but we corrected it.
Yeah.
And then what other ones did we get wrong?
12
12 we got wrong?
with 1.036. But if
But we
you
corrected
fixed
it.
10, that would have fixed 12.
Yeah, and I fixed it, and it's 1.067, so we should have that one right.
And 13 was wrong with 0.350.
What did you get for that one?
That one I just took 35 divided by 100, and I got 0.350.
Okay. And 15 we got wrong too.
Yeah. And 17.
Oh my gosh, I got like everything wrong. I don't know.
I just don't know what to do for 15 or 17.
I don't know.
There is
I
great
don't know what to
distant
do here.
loss.
Okay. Whatever. I'm done. Do we have anything else we have to do? We have to do this thing. Final project overview. What's that?
Did you submit it or?
Yeah.
Oh, what'd you get?
I got one wrong. I got number oh my gosh. I got number let's see here, number 15 wrong. Negative.